Let us get middle school students interested in STEM. Focus on robotics by making radio-controlled vehicles autonomous.
At the touch of a button, the available advanced parking guidance system can parallel park the LS with just a little brake work by the driver.
There it is without the covering on it. I just little by little show you each part. Note the complicated and complete suspension system with shock absorbers, springs, tie rods. In the back, differential, gas, DC motor, gears, differential. And there's even, you can't quite see it very well, there's a belt in there which connects things to four-wheel drive. But more importantly, what I've added. First thing to see here is a prototype board. No solder. The interconnect wires are 22 gauge solid, and they plug into little holes without soldering. And what's in there? Well, that big chip there is a microchip 16F887. There is a TI SN7407 current driver, which interfaces between the microchip and that Zettler double pull, double throw relay switch, which requires more current than the chip can provide. Back here is the radio receiver from the original car. It connects via that complex thing to the electronic speed control, which in turn drives the wheels through that DC motor there. In the front of the car is a pair of sonar rangers, and on the right hand side of the car is another pair of sonar rangers, and they detect the speed of ultrasonic echo running at 1100 feet per second, and of course the timing of the microchip in the millionths of a second can parse this down to inches. Down here is a small potentiometer which I have set up such that the microchip reads the position of the pot and decides whether to go fast or slow, and I have 7 different positions on that. That little connector, 6-pin connector there, is what connects to the USB port on my computer. These wires there connect between the computer, the PIC and the sonars. These wires here again, PIC and sonars. These wires between the radio receiver and the prototype board and basically to the PIC. And these wires from the PIC to the ESP so that the ESC knows what pulse width modulated signals to use.
Now I'd like to focus on the Lexus, and its ability to park was dependent upon having a microprocessor and some method of detecting objects in front of it and behind it. Those are the sonars. So my little car could in fact do parallel parking. It's not designed for that. I have designed it for going forward and running around a wall counterclockwise looking down, and racing other cars doing the same basic thing. What I'm going to show you right now is this car in my garage going slow. can't see it very well, but through the hole in the skin, you can reach a pot, and that pot is detected by the computer and makes the car go fast or slow. I've got it here set very slowly because there's a small garage, and I have to have the turning warning set short. I do have control over the car with a radio transmitter, standard sugar type radio transmitter, and I can make the car come back a little bit or go forward a little bit. Here's back, here's forward. I can turn it to the right or to the left. It's hard to do that and at the same time do this video. So I will turn off the transmitter and let it go. As you can see, it's been quite successful so far. The trick is to change a couple of components in the basic program so that the throttle goes much faster and the indication that I have to turn left is much faster. That's it. Oh, notice it finds its way out. We're racing the two cars. That one's going in this corner. Very hard to follow. You can hear the other one, which is in this corner. Alright, they're both near each other. You can see them. Here comes the other one. Alright, here they come. Uh-oh. Alright, the toy car's winning right now. Alright, you can see the toy car cheated because it took a shortcut. But it's still coming along. The toy car's on its way. This one is right at my feet. The toy car is clearly winning. Toy car stopped. I have to go fix the toy car. Oh, they're both stopped. Okay, well, I'll start the toy car first, make it fair. Uh-oh. He stopped. we go. 2 of them. Maybe this is a good spot to watch it from. Toy car had a problem. As soon as it gets going the wrong direction, it's helpless. There we go, catching up. The toy car cheats. The model level car plays better by the rules, but toy car gets ahead. As you can see, toy car just spun itself around. It's completely confused now. Oh, I think it's had it because it's now against the wall, going the wrong direction. All its programming doesn't know what to do with that. This guy's still going strong. I gotta fix the toy car. Alright, there he goes again. Toy cars run out of juice. Model car does a pretty good job, you can't deny, as far as doing what it's supposed to do.